A farmer uses a lever to move a large rock, and here he is. The force required to move the rock varies inversely with the distance from the pivot point to the point the force is applied. A force of 50 pounds applied to the lever 36 inches from the pivot point of the lever will move the rock. Which function models the relationship between F, the amount of force applied to the lever, and D, the distance of the applied force from the pivot point? Alright, this is a math application problem. You see these types of problems a lot in physics. Okay, even if you don't know anything about physics, you still have what you need to kind of figure this problem out. Let's kind of look at the vocabulary and understand the situation. Okay, so there's force required to move the rock. It varies inversely. What is an inverse relationship? It means when one thing goes up, the other thing is going down. And when I say thing, I mean like when the independent value goes up, the dependent goes down. Or the independent goes down, the dependent goes up, and vice versa. Common examples would be like, the more you brush your teeth, the fewer cavities you'll have. The brushing teeth is going up and the amount of cavities is going down. Something like that. Okay, so in this situation, it says we have which function models the relationship between F, the amount of force applied to the lever, and D, the distance of the applied force from the pivot point. Okay. If the force is greater, the greater the force gets, the smaller the distance can be from the pivot point, and vice versa. The less the force is, the greater the distance is going to have to be from the pivot point. So here's the force going down, and here's the distance from your pivot point. Now we have two numbers here. We have a force number, 50 pounds, and we have the lever, 36. And here's what I'm saying here. Before we do anything else, we have the 50 pounds is our F, and the 36 is our D for distance. Really, if we have like an ordered pair here, or we have a 50 we can plug in for F, and we have a 36 we can plug in for D. And really, one of these equations is going to work, and the others probably will not work. Let's go ahead and plug those in and try. So here we have D equals F divided by 1800. That would be 36 equals 50 divided by 1800. Now when I do 50 divided by 1800, I don't think I'm going to get 36. No, I get like some crazy decimal, right? So choice F does not make any sense. It doesn't work. D equals 86 divided by F. D is 36 equals 86 divided by F, and F is 50. Let's see if we get, and I'm thinking it's not going to work, but let's try it. 86 divided by 50. We get a weird 1.68. We do not get 36. So that doesn't work. F, which is 50, equals 1,800 divided by 36. So let's do 1,800 divided by 36. We get 50. That one works. So this one is a definite contender for being the right answer. The last one, F, that would be 50 equals D, 36, divided by 86. That's not going to give me 50. 36 divided by 86 gives me some weird decimal. So, just by plugging in the numbers in the right spot, this hard-looking situation where the picture that might be hard for some of you guys to understand, we just plugged in the numbers. We didn't even need any of that stuff. We got the right answer.